let's continue to question 2. It says calculate the heat of reaction, or delta H, for the following reaction. 2HCl plus Br2 makes 2HBr plus Cl2 gas. So in this problem, we have to use the table of bond energies that you were given in ALEKS. I did not have access to that exact table, so I had to use other tables that I found elsewhere. So here's the problem. It's 2HCl plus Br2 makes 2HBr plus Cl2. In order to do this problem, we simply have to do the summation of the bonds broken minus the summation of the bonds formed, and that will give us our answer. So in order to do that, we see how many bonds are there in this first piece. So it's 2 times whatever the amount of energy is for an HCl bond. So I found an HCl bond to be 431. Yours might be slightly different, so make sure to check that before you do this problem. And then plus, so Br2 is a Br-Br bond, and I have that at 190. And so minus, now it's 2 times HBr, because there's two HBr, so there's 2 HBr bonds, and HBr bond was 370, plus the Cl2 bond, which is 243. And upon doing the summation parts, we end up getting the left side to equal 1052, and the right side equals 983. So our delta H is 69 kilojoules per mole. Okay, if you need to, pause this video. If not, I will be erasing this and starting the next one. Alright, the next problem states that we have to calculate the heat of delta H for the next reaction. So it's 2CH4 plus 3O2. So this is the exact same process as we did previously. Okay, and here we go. And now we have this problem. So all we have to do is look in the table for the different bond energies, and we calculate the numbers just as we did in the previous problem. So it's 2 times the bond of CH, because each one of those has 4 CH bonds. So it's 2 times 4 times the energy of a CH bond. So the energy of a CH bond is 413. Okay, and then that's plus 3 times the energy of an O2 bond. The energy of an O2 bond is going to be 495. Again, this is the numbers that I have in my chart, but your chart might be slightly different. Minus 2 times the energy of a CO bond. Now, the bond in CO is actually a triple bond. So in carbon monoxide, that's a triple bond. So the triple bond between a C and an O is 1072 in energy. And now we have to add plus, so it's going to be plus 4 times 2 times the energy of an HO bond, because each water contains 2 HO bonds. And the energy of an HO bond is 463. Okay, so let's do our math here. And if we complete the left side, we'll find that it equals 8,093. The right side equals 5,848. And the summation, or the combination of these two numbers, ends up being 2,245 kilojoules per mole. And that's it for this problem. Alright, now I'm going to erase this problem, and we are going to begin the next problem. Okay. The next problem says, it takes 463 kilojoules per mole to break an oxygen-hydrogen single bond. Calculate the maximum wavelength of light for which an oxygen-hydrogen single bond could be broken by absorbing a single photon. So this is actually the exact same type of problem as the first problem that we covered in that other video, and you solve it the exact same way. So we have 463 kilojoules per mole. We have to times it by 1,000, and we have to divide it by Avogadro's number. And upon doing that math, we end up getting the number of 7.688 times 10 to the negative 19th joules. So that's the energy that it takes to break one of those bonds. Okay, now if we know that, we can now plug into that equation that we used before, which was lambda equals hc over E. Okay, h is 6.626 times 10 to the negative 34 times 3 times 10 to the 8th divided by 7.688 times 10 to the negative 19th joules, which is the energy we calculated. And upon doing this number, you end up getting 2.585 times 10 to the negative 7. As we did before, we're going to want to put this in nanometers. So, and we want it to be significant figures. So we want it to be 3 significant figures. And if we put this in nanometers, it becomes 259 nanometers. And that is the answer for this question. Okay, let's continue. So the next problem, let me erase this board quickly. Okay, the next problem says calculate the heat of reaction delta H for the following reaction. CCl4 plus H2. Oops, let me fix that. CCl4 plus H2 makes CHCl3 plus HCl. Alright, and we have to do this the exact same way that we did the other problems, so we would use the respective bond energies that we would find in the table on Alex or in the table that I found. So for this problem, we have 4 bonds in this first part. They're all CCl bonds, so the CCl bond is 328 plus the amount of energy for an H2 bond, which is 436, minus, now we have to do this problem. So in this part, we have 3 bonds that are CCl bonds, which is 328. And we also have a bond which is a CH bond. So we also have to add the energy of the CH bond, which is 413, plus we add the HCl bond, which is in that last piece, which is 431. Upon doing our math, we end up getting 1748 on the left and 1807 on the right, and our total answer is negative 59 kilojoules per mole. And that's the answer to this problem. Alright, again, if you wanted to pause this video at any point, you could do so, and then start it up again when you're ready. And now that I'm finished erasing the board, I will continue with the next problem. So the next problem states, estimate the enthalpy change, delta H, of the reaction below using the bond energies given in the table. So in this equation, they actually showed us structures. So they had H with a C, double bonded to another C, bonded to an H. They also had plus 2F2 makes And then I have this big structure. Okay, so this is the exact same type of problem as the previous problems, and in order to do this problem, all we have to do is look in our table. Thankfully, instead of looking on an Alex table, we have our own table here, and we can do the problem through that table. So if we look at the first structure, we see that we have two types of bonds in that. We have a C triple bond C, and we have two bonds that are both the same. They're both CH bonds. So it's 2 times the amount of energy in a CH bond, which is 415, plus the amount of energy in a C triple bond C, which is 837, plus 2 times the amount of energy in an FF bond, which is 160. Minus, now if we look at this structure, we notice we have 3 different types of bonds here. We have a single carbon-carbon bond, which is 345, plus we also have 2 carbon-hydrogen bonds, which is 415 each, and we also have 4 carbon bonded to fluorine. So that would be 415. I'm sorry, not 415. That is the wrong number. That would be 439, based on the table that they gave you. And upon doing this math out in your calculator, you would obtain the answer of 1987 on the left and 2931 on the right. And if you notice, this is going to be a negative number. We end up getting negative 944 kilojoules per mole. Perfect. Okay, that's it for this problem. Again, this is the same type of problem that we have seen previously, and you use the same process to figure it out. Here, it's easier because they gave you the table